What's going on, y'all? We're going to go over some of the most missed questions on our test. I'm going to share my screen, and then we're going to go over those, and that's all you're going to have for Monday. Right, start off strong. All right, which pair of properties, number 2, which pair of properties describe the elements in group 18? Remember, group 18, those are our noble gases. Okay, and our noble gases are chemically stable. They're chemically stable, and they're gases at room temperature. Okay, so A says they are chemically stable. That's correct, but they're not liquid at room temperature. They have 8 valence electrons and are flammable. So this is what is going to trip us up. First of all, most of them aren't really flammable, and helium has 2 valence electrons and is still a valence electron, so not all of them have 8. They are magnetic and boil at low temperatures. Well, that's just wrong. So they are gases at room temperature and chemically stable. Another highly missed question is number 1. A chemist made the table below to record some atomic properties of 4 elements. Based on the information in the table, which conclusion about the chemical reactivity of these elements is valid? Boron is most reactive because it has the most protons. We have not talked about that one bit. I'm looking for chemical reactivity. That is, chemical reactivity is the trigger word to valence electron. So as soon as somebody says chemical reactivity, you should automatically be thinking valence electrons. All right, fluorine is the most reactive because it has 7 electrons in the outer shell. So that's 7 valence electrons. That seems like a good choice, but let's see if there are any other good choices. Silicon is the most reactive because it has equal number of protons and neutrons. Again, have not said anything about chemical reactivity in protons or neutrons. Gallium is the most reactive because it has many more neutrons than protons. For the third time, haven't said anything about chemical reactivity in protons. So my answer is B. Which statement correctly describes the location and charge of the electrons in an atom? My electrons, that's the location and charge. The electrons, remember electrons outside, my electrons are very, very negative, right? So the electrons are inside. Well, I know that's wrong. The electrons are outside. Okay, that's right, but they do have a charge. The electrons are inside. Well, the negative charge is correct. And the electrons are outside, correct, the nucleus, and have a negative charge. That is also correct. So my answer is D. All right, we're going to skip a little bit to number 6. Elements R and elements Q have the same number of valence electrons. These elements both have similar chemical behavior, but element R has fewer energy levels than element Q. All right, so look, element R has 1, 2, 3 energy levels. So it's in the third period. Element Q has 1, 2, 3, 4 energy levels. So it's in the fourth period. All right, so I'm looking for something that says that they are in the same group, but not the same period. The 2 elements are in the same period. Well, I know that's wrong. The 2 elements are side by side in the same period. Well, I'm not in the same period. The 2 elements are in the same group with element R just above element Q. Okay, that one makes sense. The two elements are in the same group with element Q at the top of the group and an element R at the bottom. Okay, so if element Q is at the top of the group, it would have either one period or two periods, one or two energy levels. It has four, so I know it's not going to be at the top. The two elements are in the same group with element R just above element Q. So they are right on top of each other. And if I actually look at a periodic table, so the two elements were magnesium. Element R is magnesium right here. I know that because it had 12 protons, so you could have just looked at that. And then calcium right here was element Q, and element R is just on top of element Q. You are more than welcome to always use a periodic table. Please do not tell me that it was not fair. You had a periodic table to use. All right, which best represents a neutral lithium atom? So I know lithium has 3 protons. We can look here. Again, lithium is right here. If you didn't remember, could have used your periodic table. So lithium, I'm going to draw my own. So I'm going to have 3 protons. I'm going to have 4 neutrons because the atomic mass was 7. All right, then I'm going to draw out. I have 2 electrons. I can only have 2 electrons in my first shell. Draw my second energy level. Put my last one. So now I'm looking for something that has 3 protons, 4 neutrons, 2 energy levels. Well, A doesn't have 2 energy levels. B, I have 1, 2, 3 protons, 1, 2, 3, 4 neutrons, and then 1, 2, 3 electrons. So that one's looking pretty good. C, I have my electrons are inside my nucleus. Well, that's not right. And then D, I have 1, 2, 3, 4 protons and 1, 2, 3 electrons. So it's supposed to be beryllium because beryllium has 4 protons, but I'm looking for lithium. So then I know my answer would be B. Which 2 elements on the periodic table are in the same period? Remember, my periods go across. So period 1, hydrogen, helium. Period 2, right there. Period 3, 4, 5, 6, and 7. So SN and RB. So I'm going to do those in red. SN is right here. It's 10. RB. Oh, look at that. Right off the bat. They're both in period 5. Let's see if there's any other possible answers. So my next one's fluorine and chlorine. All right, fluorine, chlorine. They're in the same group. Remember, groups go up and down, but periods are at the end of our sentence, and we read left to right. So, no, it's not fluorine and chlorine. Potassium and don't know what Ba is. So we're going to find these in green. So here's potassium, Ba, Ba, right here, barium. Those are not in the same group nor the same period. And then finally, Se and Te. Let's see if we can find them. Here's written. All right, and these are in the same group, but not the same period. So then my answer has to be A. The atoms of a certain element contain 11 protons and 1 valence electron. So let's find what 11 Which statement correctly identifies this element and describes its chemical reactivity? So I have 11 protons, so then I have, it's sodium, because protons determine the element's identity right here. And then one valence electron. So remember, the closer I am to a full outer shell, the more reactive I am. So if I draw sodium, a full valence electron there, and then I just have one valence electron, so I got to draw my one more. All I have to do is get rid of this one valence electron, and that's easy for them to do by just erasing it, or by me erasing it, I'm simulating a chemical bond. All right, so it'd be an ionic bond, but I'm very, very reactive because I'm so close to winning the game. I'm so close to a full outer shell. Groups 1 and 17 are the closest to a full outer shell, so they're the most reactive. So a lot of us had that it was sodium, but did not put that it is highly reactive. So the element is sodium, and it is highly reactive. That's why we get so much table salt, is because sodium and chlorine are so reactive that they're constantly reacting. Based on the periodic table, sodium, I'm going to highlight it in blue, and sulfur, S, blank. Are they both metals? We really haven't talked about metals, but sulfur is a non-metal. Anything to the right of our little staircase right here is a non-metal. All right, so they have same physical properties. Well, they're not both metals. Also, we haven't really talked about physical properties. They have the same atomic mass. Sodium's mass is 23, sulfur's mass is 32. 23 and 32 are not the same. They have the same number of energy levels. Remember, they're both in period 3, so they're going to have the same amount of energy levels. And finally, our last one that we're going to go over. Which statement best explains why protons are used to identify an element? The number of protons is unique to each element and remains constant. Okay, anytime I have 3 protons, I'm lithium. If for whatever reason I add a 4th proton, it changes and I'm now beryllium. Okay, so the number of protons is unique to each element and remains constant. And I don't have any other ones. If you have a question over any of these, please let me know. If you have a question over any other one of the test questions that we went over, please let me know. You can go back into CMS and look at the questions you missed. All right, and if you have trouble doing that, ask me and I'll walk you through step by step of how to do that. All right, y'all have a great day. I'll see y'all tomorrow. Bye.